Alright, so today we're going to talk about the infamous logarithms. This is always the end of the first semester in Algebra 2, and it's always the funnest, I think, to teach it because it's so different from what you've learned before. But if you think about it and how we've done math, this is actually pretty darn close to what we've been doing. Okay, so if we think about solving equations, if we think about working backwards, now this arose from the need of inverses. So what you see and what you do, two different things. Okay, so if you see addition, you do subtraction. If you see subtraction, you do addition. If you see multiplication, you do division. And if you see division, you do multiplication. So this all arose from these facts like, okay, how do we solve an equation? Now, if you see squaring, okay, you do square rooting. And if you see square rooting, you do squaring. And it's as simple as that. So we've got this stuff down, okay? And also the same thing can be said for raising to any power. So like, for example, if we have the cube root, we'll just say n root, okay, you raise to n power, okay, and that's the inverse. And then same thing over here. If you see a problem where you're raising something to n power, and we just learned this last section, you do the n root. Okay, so those are all inverses. But now we've been given a problem where, what if we have something, let's say a, and the exponent has the x. What is the inverse of that? And that actually is log base a. And that's the amazing thing about it. And logarithms are actually the inverses of exponential functions. Okay, and same thing over here. If we have log base a of a number, the best way to solve it is to do the exponential. So this is another feather in our cap, another tool in our box to actually solve equations. And this is where logarithms really come from. It's just the fact that you're dealing with an exponential base. Okay, how do we work with it to actually get the actual inverse? Okay, alright, so here's what we need to start talking about, is the actual definition. So logarithm, normally exponents say exponential models ask when a number is raised to a certain power, what do we get? So that's what an exponential model asks, or model. Apparently I'm in the state of asking questions from like Canada. Okay, now logarithm asks instead, what power gets us a certain number? Okay, so let's bring this over here. Alright, so in other words, instead of asking us like, okay, 2 to the 6, what does this equal? Oh, that equals, let me see, 2, 4, 8, 16, 32, 64. So that should be 64 as an answer. But now it asks, instead, 2 to what power equals 64? And that answer is 6. Okay? Alright, so what we're doing with logarithms, and so this is exponential, we'll call it expo, and this one's log. Okay? Alright, so it's just the reverse of what we're talking about. Alright, so we need to come up with an idea to compare the two. So let's have an exponential model. Let's say a to the x equals y. Y is typically our answer, so this is the exponential model. Okay? Now, how do we change it over into the log model? Okay, let's say that this is a model. Alright, so this. Alright, what I like to do, and this is a little hint, okay, this is the base. This will make sense when I get through with that. And this is the exponent. Everyone's probably going, gee, Mr. Devaney, you are so explanatory. Well, you'll understand where I'm getting these rules in a second. Okay, and then this one is my answer. Okay, it will all make sense in a second. So answer. Okay. If you notice when I was saying something, log base A. So I'm going to take this base and put it next to log. So when I change it to the logarithmic form or logarithmic model, I'm going to say log base A and then I put y right next to it equals x. Okay, now it's kind of hard to see this in this case. Let me break it apart a little bit. Let's make it a little bit easier to read. Let's get rid of this. Okay, I'm going to put an A right here, and this is typically where it goes. Log base A. Okay, so the base goes down here. The answer moves right here, and the exponent moves to the other side of the equation. Because remember, logs are asking what power gets us a certain number. So if the power is the answer, then I better put the exponent over here. Okay, so I move the base next to the log, I put the answer right here and just work with it. Okay. Alright, let's take a look at some actual questions. Let's go log, and I'm going to have to write out the base. It's going to take too long to type the subscript. Okay, log base 5 of 125. So what this is saying is what power do I have to raise 5 to get 125? Okay, so that's what log bases are asking. And that power, if you already know, is 3. Okay, now what if I did log base 8 of 1 over 64? Okay. Alright, so it's saying, what power do I have to raise 8 to get 1 over 64? Now, if you notice, 1 over 64 is a fraction, so I'm going to actually be raising it to a negative power, and that power is going to be negative 2. Because if you check it, 8 to the negative 2 is the same as 1 over 8 squared, which is the same as 1 over 64. So that's how you can do it by hand. I'm going to show you how Desmos does it, and it's pretty sick. Alright, so now if you try to type base into here, it's not going to be going as well. So what we need to do is we need to use a little known fact on the keyboard. So I'm going to bring your attention down here. So you go down to the keyboard, you press A, B, C, and you see this button right here, and it's subscript. Okay, so I'm going to type in log. Alright, so when you're in here in log, okay, you want to be as close to log as possible. Until you type log, it's not going to actually recognize it. As you can see, the difference in from italicized to just regular script. Okay, when I press the subscript, it's going to appear down here. So log base 2, you have to click back up or move to the right, okay, to get this out. So if I put it in here, well, actually, that doesn't even help. You have to go back and press the subscript button, or nope, just press space. Log base 2 of 32 is 5, and how do I check that? Check 2 to the 5th. It gets me 32. Voila. And you can actually work with this stuff. Okay, and so that's just how log works. It just is asking this question, is just going, okay, 2 to what power is 32? and 2 to the 5th is 32. So that's how this actually works. Alright, so we've talked about logarithmic. A logarithmic function is just basically something where it's y equals log base some number a of x. You know, the x would be the actual answer for the typical problem. Okay, so that's the logarithmic function. Now, logarithmic scale is actually really kind of cool in that you're dealing with a scale. So if it's a logarithmic scale, and let's talk about the Richter scale because it's one of the more famous ones. Okay, so this right here, you can actually tell it by powers and magnitudes of 10. Okay, so the logarithmic scale of 0.0, which is impossible because the Earth's crust is pretty much always moving. All right, to go from 0 to 1, you are increasing by power of 10. Okay, ugh, that's ugly. Okay, now if we go from 1 to 2, you are increasing by a power of 10 again. And that means to go from 0 to 2, you are increasing by a power of 100. So you're actually increasing by quite a bit. And so on and so on. So each step is you're increasing by 10 times the amount. So the difference between a 4.6 and a 5.6 earthquake is about 10 times as powerful. It's just working across that way. Okay. All right. And then common log is one of the more, well, pardon the pun, but it's just a common log. All right, but common log is log base 10. Okay. So in other words, from now on, whenever you see a log from here on out, so log base of 1,000, this is actually saying log base 10 of 1,000, which should be 3. So if you actually put that into your calculator, if you just put in log of 1,000, it's going to be 3. Okay. Alright, so something as pretty simple as that, you guys, just working with the logs. Just remember to press the ABC button and then press the subscript button, which is down underneath the X and Z. Okay, and just when you're working with this stuff, please, please, please take your time and just understand that here's a cool thing about logs is each time you go up by a power of 10 in the common log, you're going to be increasing the power. Now if I go up here and change this to 2, it's power of 1. If I change this to 4, 2, 8, 3, 16, 4, 32, oops, 32, there you go, 64, 6, you know, and it just works that way up. And same thing works with the logs. So each time I add a 0, it moves the power up because now this is asking 10 to the 5th power is 100,000. Okay? All right, and just take your time. Logs can be very appreciative. And just remember, this is the inverse of the actual function. Well, shoot, let's go ahead and graph it. What am I doing talking about this? Okay, let's get rid of this. Boom, boom. Okay, so y equals 2. Now let's go y equals 10 to the x power. Okay, so here's the actual graph. Y equals log of x. Okay, and if you remember, we talked about the inverse functions and testing them out. As you can see, perfect inverses of each other. And remember, this is common log, so this is log base 10 of x. Okay. Now, if I wanted to graph 2 to the x, oh, geez Louise. Let's raise that to the x power. Okay, this would need to be log base 2. So I'd need to get right next to it, put in my base as 2, and there it would go. Okay? All right. That is it for talking about logs. I'll talk to you guys later.